In this lesson, you are going to see the ideas of volume and exponents related a lot. And to understand the reason for that, we need to go back to our formula for volume, how we find volume of a figure. So in previous grades, we have talked about it as length times width times height. And that is going to stay true for us. But the reason that's going to work with exponents is because of a shape that I've drawn here, and those are cubes. Now, there's something special about cubes that we need to remember, and I have a little asterisk for that over here. It's that cubes have all equal side lengths. So if every side is equal to the same thing, well, then our length, our width, and our height are all going to be the same number. And that's where the exponents come in. Let's look at this blue cube here. If you are told that there's a cube and that one of the side lengths for this cube is, let's say, 7. Well, that means every side length on this cube is also equal to 7 because cubes all have all equal side lengths. So you could say that the volume of this blue cube here is equal to 7 to the power of 3. And the way you can call that as well is 7 cubed. You may have heard that reference. And the reason we say cubed is when it's to the power of 3, that means there are 3 dimensions. So here is our cube here, 7 cubed. So of course, from our last video, we know that means 7 times 7 times 7. And we don't really need to know the exact answer of that for the purpose of this video. But that is how we relate our volume to exponents. Let's look at this red cube now. Let's change the side length. I'm not going to call it 7. I'm actually going to call it, let's say, M. Well, if every side is the same, that means every side is M long. Now, instead of writing it 1,000 times around this cube, and if we're just looking for the volume, I'm going to say volume is equal to M cubed. M to the power of 3. And that is why you're going to see volume and exponents related.